Okay, this is a quick worked example for discrete random variables. So we're given some pieces of information here. Suppose that x is a random variable with an expected value of x squared of 3.6, the probability of x equal to 2 equals 0.6, and the probability of x equal to 3 equals 0.1. Okay, so the random variable x takes just one other value besides 2 and 3, and that value is greater than 0. What is this value? Okay, so it could take some number, and it could be a real number like 1.5 or 1.7 or something like that. And it is obviously a positive number and not necessarily an integer. But anyway, we have to find it. And we do have enough information to find it. Calculate the expected value of x and then calculate the variance of x. Okay. So first off, what we have to do is, so we know that there's one value, okay, and we're going to call that value k. And what we have to do is determine the probability of that, okay? So we're going to set up our little table here, our probability table, okay? 2, 3, and k. And the x squared values are 4, 9, and k squared. And we know that the probability of 2 is 0.6 and the probability of 3 is 0.1. So necessarily, this must be 0.3. Okay? That's good so far. So yeah, this is it all set up there. I had that sort of set up in multiple tables, a bit of overkill. Okay. Now, we are told that the expected value of x squared equals 3.6. So that is the sum of each of the values squared times the probability of that value. So 2, 3, and k. So 2 squared is 2 times 0.6, 9 times 0.1, and k squared times 0.3. That gives us 3.6. Okay. So 2.4 plus 0.9 plus k squared times 0.3. So I'm just down here, a bit of duplication going on there. Okay. Equals 3.6. Okay. So that's 3.3 plus 0.3 times k squared is 3.6. That means 0.3 times k squared equals 0.3. So k squared is equal to 1. Okay. We also know that k is greater than 0, so it's not minus 1. Okay. So k squared equals 1, therefore k is equal to 1. Okay. Now, just as a remark, if we were not given this, it could equally be minus 1. Okay. But that sort of clarifies that it has to be 1. Okay. Now, so essentially what we have to do here is calculate the mean and variance of x. Sorry, that should be the mean and variance of x. Okay. Well, actually, do you know what? Ultimately, this is the end goal. So let's just keep going with this. So the variance of x is equal to the expected value of x to be squared minus the expected value of x squared. Okay, or x to be squared, or the expected value of x squared minus the expected value of x to be squared. So just notice the brackets there. Okay. Now we already know that the expected value of x squared is 3.6. So what we have to do is compute the expected value of x, the mean of x. Okay. So really this should be straightforward enough now. So we multiply each possible number there, each of the possible values of x by its corresponding probability, and add them all up. So 2 times 0.6, 3 times 0.1, and 1 times 0.3. That gives us an expected value there of 1.8. Okay. So to compute the variance of x, essentially just use all of the information that we've gathered. The variance of x is the expected value of x squared minus the expected value of x to be squared. So that's 3.6 minus 1.8 squared, 3.6 minus 3.24. That gives us an answer of 0.36. That is the variance of x. So that's it there. That's all of the information that we're required to gather. Okay, that's great. We'll leave that there. That's a discrete random variable worked example.